Bacelli Makina has successfully delivered a turnkey hot rolling mill solution in Turkey, designed for an annual production capacity of 300,000 tons. The system processes 150 by 150 by 6,000 millimeters steel billets into round bars, with diameters ranging from 8 millimeters to 32 millimeters. Central to the line are 15 fully integrated rolling stands arranged in a continuous configuration, enabling precise reduction and high-speed throughput. The process begins with billet reheating in a high-efficiency furnace, followed by progressive deformation through roughing, intermediate, and finishing stands. The mill includes advanced loopers, guides, and water cooling boxes to ensure optimal rolling geometry, surface finish, and metallurgical properties. A high-speed flying shear system enables precise cutting to length, while automatic bundling and stacking systems streamline post-processing and logistics. The entire operation is managed via a fully automated PLC SCADA control platform, ensuring consistency, minimal downtime, and real-time data tracking. With this project, Bacelli Makina demonstrates its engineering excellence in providing robust, efficient, and high-output hot rolling solutions, tailored to regional and global steel market demands. Timber bolts at Portland Bolt are manufactured from A36 mild steel, received in 20-foot lengths. The steel is first sheared to required lengths, then the bolt head is hot forged by heating the bar to 2000 degrees Fahrenheit using an induction coil. Roll threading follows, where threads are formed by pressing the bar between dies, maintaining material integrity. After threading, bolts undergo surface preparation, caustic soda cleaning, acid pickling, and rinsing, before hot dip galvanizing in 840 degrees Fahrenheit molten zinc. Excess zinc is removed via centrifuging to ensure nut compatibility. Bolts are quenched, inspected, boxed, and shipped to destinations, including marine construction sites like Heidelberg, Alaska. Eastman engine valve solutions involves a fully integrated manufacturing process focused on precision, durability, and automation. The process begins with bar shearing, where steel bars are cut into specified lengths, followed by friction welding to join materials for valves requiring composite structures. Next is shocking forging, forming the valve head through high-pressure deformation. The forged components undergo heat treatment in a continuous furnace to achieve required hardness and microstructure. A seat deposit process is then applied to improve wear resistance. In the machining area, valves are automatically loaded by bowl feeders to ensure consistent flow into the rough end grinding operation, followed by profile turning, groove grinding, and head diameter turning with facing. Induction hardening of the end and finish end grinding further improves surface properties and dimensional precision. Afterward, seat grinding is carried out, followed by induction hardening of the seat for additional wear resistance. The final steps include chrome flash plating to enhance corrosion resistance and appearance, and auto inspection systems that ensure dimensional accuracy and defect-free components. This high level of automation and process control ensures Varex engine valves meet strict OEM performance and reliability standards. To complete the process, valves undergo comprehensive quality checks, including dimensional verification, surface integrity assessments, and hardness testing. Varex integrated automation not only enhances throughput, but also minimizes human errors, ensuring consistent production of high-performance, emission-compliant engine valves for global automotive platforms. The BSM 250RROR cage welding machine is a high-efficiency solution engineered for the automated production of reinforcement cages used in the manhole and concrete pipe industry. What sets this machine apart is its patented round-oval-round (ROR) welding technology, enabling the formation of variable cage geometries with seamless transitions. This innovative design dramatically optimizes the distribution of reinforcement material, making it possible to reduce steel usage by up to 50% without compromising structural integrity. The BSM-250RROR automates the welding of longitudinal and spiral wires into highly precise cages, ensuring consistent quality and strength. With programmable parameters and user-friendly operation, the machine can quickly adapt to different cage specifications, allowing for maximum production flexibility. The welded cages support the concrete pipe and manhole segments during casting, offering the durability required for infrastructure applications. Thanks to reduced material consumption and minimal operational waste, the system not only cuts costs but also aligns with modern efficiency and sustainability standards. Designed for reliability, repeatability, and industrial scale output, the BSM-250RROR is a strategic asset for any concrete precast production facility. The CM12CN multifunction threading and chamfering head from Revax Machinis is a fully programmable, high-precision tool designed for a wide range of metalworking operations. It performs chamfering up to specific diameters with consistent accuracy, making it ideal for components that demand clean, precise edges. This advanced head supports both cutting die threading and thread rolling, lamination, offering manufacturers flexibility depending on material and application requirements. Thread rolling ensures stronger threads and improved surface finish, while cutting die threading remains suitable for specific profiles or low-volume runs. In addition to threading and chamfering, the CM12CN can also operate as a wire bender or be integrated into a wire reeling system. When paired with a feeder, it becomes highly effective for the automated production of springs or complex wire forms, streamlining operations and reducing the need for multiple machines. With its robust construction, programmability, and multifunctionality, the CM12CN is a valuable solution for manufacturers seeking to enhance productivity and precision in forming, threading, and chamfering processes. From a glowing solid steel bar to a perfectly formed seamless pipe in minutes. What makes Tenaris Bay City's process so extraordinary? Behind each steel pipe lies a symphony of automation, precision, and metallurgical control that redefines modern manufacturing. The Tenaris Bay City Seamless Pipe Manufacturing Facility represents a pinnacle of modern steel production. Beginning with precision-cut solid steel billets, the hot rolling process transforms them into hollow blooms using a barrel-type piercer via the Mannesmann effect. These blooms are elongated, reheated for temperature uniformity, and resized in the stretch-reducing mill. Heat treatment follows. Pipes are austenitized, quenched to form martensite, then tempered to regain ductility. Dimensional corrections and straightening ensure tight tolerances. The finishing line performs hydrostatic testing, electromagnetic and ultrasonic inspections, then threading, coupling, and drift testing. Pipes are lacquered, weighed, stenciled, and automatically bundled. This high automation, low impact process ensures every pipe meets stringent mechanical and dimensional standards, ready for critical service. Maan and Shahid Forgings Limited, MSF, established in 1974 in Lahore, Pakistan, has grown into the country's largest forging enterprise. Initially producing 250 tons of forged parts annually for the railway and gas sectors, the company led the domestic development of automotive forgings in the 1980s. Today, MSF operates 2 forging plants and 1 machining facility in close proximity, offering a fully integrated manufacturing solution. The company is an accredited supplier to OEMs like Massey Ferguson tractors and Atlas Honda motorcycles, and has been exporting since 1996, with international sales now accounting for nearly 40% of total output. Production begins with the selection of raw materials from over 30 steel grades and sizes, all of which undergo rigorous metallurgical and mechanical testing. Steel billets are sheared and heated to temperatures up to 1,250 degrees Celsius using induction heaters. Forging, trimming, and hot coining are performed, followed by in-house die manufacturing using advanced CAD/CAM design and CNC machining. Forged components are normalized or isothermally annealed in gas-fired top-hat furnaces, ensuring dimensional stability. Heat treatment continues with hardening and tempering in precision-controlled electric salt bath furnaces. To remove scale and detect defects, parts are shot blasted and visually inspected. Magnetic particle inspection, MPI, ensures crack-free surfaces. Components requiring further processing are sent to the machining plant, where CNC turning, milling, hobbing, broaching, grinding, and drilling are performed under strict quality control. Induction hardening is applied to axles and spindles up to 1 meter long. Precision is verified with CNC coordinate measuring machines. Final steps include degreasing, rust prevention, and protective packaging using VCI materials. Through state-of-the-art processes and uncompromising quality standards, MSF consistently delivers forged and machined components for both domestic and international markets.
Millennium Rings, established 2005 in Rajkot, operates 3 seamless ring production lines within a 72,000 square feet facility, delivering 20,000 TY of forged rings. ISO 9001 to 2015 protocols govern every stage. Certified carbon, alloy, pH, stainless and non-ferrous billets are color-coded, sawn, then induction heated to forging temperature. MPM power hammers preform blanks, followed by a 3,000 kilonewtons radial-axial ring rolling press capable of Yi 800 mm times 160 mm sections. In-house heat treatment furnaces perform normalizing, hardening, and oil-water quenching cycles to refine microstructure. CNC/VMC machining centers finish to tight tolerances, while spectrometers, ultrasonic inspection, and hardness testers validate chemistry, soundness, and mechanical properties.
Dual ring rolling enables simultaneous forming of 2 rings, increasing efficiency and consistency in profile ring production. Using precision-controlled hydraulic presses and CNC-guided rollers, the process ensures uniform wall thickness and shape. It's ideal for symmetrical profile rings in aerospace, bearings, and flange industries, reducing cycle time significantly. The Shandong Irata 500,000-ton grinding ball project features a fully automated production line, integrating billet heating, hot skew rolling, online quenching, and tempering. Each step is precisely controlled to ensure uniform microstructure, high hardness, and impact resistance, meeting the rigorous demands of global mining operations. The use of advanced alloy steel, combined with automated forging and inline quality control systems, such as laser dimension checks and ultrasonic inspection, guarantees product consistency and traceability. Robotic handling and automated storage solutions reduce labor intervention and increase efficiency. This cutting-edge facility has attracted top mining giants due to its technical capability, process reliability, and production scale. ILSAM specializes in hot steel forging for industries including tractors, earth-moving machinery, industrial vehicles, agricultural equipment, engines, motorcycles, hydraulic cylinders, and railway systems. The forging process is governed by strict quality controls, from raw material acceptance to dimensional and structural inspection, using advanced high-tech machinery. Steel deformation is carried out using double-effect hammers up to 3,000 tons, and screw or crank presses up to 2,000 tons. Additional operations include machining and heat treatment. ILSAM manages both the design and production of dies, integrating cutting-edge CAD/CAM technologies and expert craftsmanship. All production stages are handled by skilled personnel and precision CNC equipment. Goshu specializes in precision forging through an integrated process, starting from design and die manufacturing. Using a 4,000-ton high-speed automatic press, steel is heated to 1,200 to 1,230 degrees Celsius and formed accurately with custom dies. Forged parts are robotically transferred with zero-drop handling and neatly aligned for the next stage. The cold automatic line uses camera-guided robots for precise part picking from pallets, followed by cold forming and automatic loading into customer containers. The company manufactures high-precision components such as speed gears, CVT shafts, variable rack steering parts, forged helical gears, and motor shafts through hot and cold forging. The forging process of forged pipes at Yang involves a rigorous and structured quality control system spanning from raw material intake to final delivery. First, incoming steel ingots undergo chemical composition analysis to verify conformance to required standards. Next, materials are cut to specific dimensions for forging. Heating is conducted in a furnace with precise temperature control to ensure metallurgical consistency. Forging is then performed via dies or free forging methods, followed by heat treatment, annealing or normalizing, to relieve internal stress and enhance mechanical properties. Post-treatment, forgings are visually inspected for dimensional accuracy and surface integrity. Precision machining removes excess material and sharp edges, improving the final geometry. Non-destructive testing, UTMT, is carried out to detect internal flaws. Hardness and dimensional inspections validate mechanical performance. Quenching and tempering follow if higher strength and toughness are required. Another round of UT, hardness, and grain size testing ensures compliance. Final finishing includes chamfering and polishing. Dimensional checks are performed again, and accepted products are steel stamped, marked, packaged to prevent damage, stored in dry conditions, and shipped per customer specifications with traceability maintained. The aluminum extrusion process, as practiced by ILSCO Extrusions Inc., begins with billet preparation, where cast aluminum logs are cut to uniform lengths and heated to approximately 900 degrees Fahrenheit in a billet furnace. Once heated, the billet is transferred to the extrusion press. Any leftover material is sheared, and a hydraulic ram pushes the new billet through the press container. Thousands of tons of hydraulic force drive the softened billet through a preheated steel die, producing a continuous aluminum profile. As the profile exits, it is rapidly cooled via water quenching to develop the desired mechanical properties. A puller system guides the extrusion along a synchronized runout table. Infrared laser cameras monitor billet, die, and quench temperatures to ensure consistent processing. After extrusion, profiles are cut at billet seams, cooled, and stretched to relieve internal stress and ensure straightness. They are then cut to customer-specific lengths and undergo artificial aging in ovens to harden the metal and finalize mechanical characteristics. Secondary services such as deburring and surface finishing are available, with extrusions delivered after final inspection. Precision temperature control and integrated quality monitoring are key to producing reliable aluminum components. Verix Engine. In Colma, Colombia's largest machete manufacturer, is a vertically integrated company that operates with a focus on technical precision, large-scale production, and export-grade quality. Founded in 1960 as the Industria Colombo Alemana de Machetes, Colma started as a joint venture with German partners following World War II, introducing European forging techniques to Colombia. Today, the company operates 4 specialized manufacturing plants dedicated to machetes, scissors, drill bits, and general hand tools, with a strong emphasis on metallurgical control and automation. The core of Colma's machete production begins with the procurement of high-quality steel, sourced primarily from England and South Korea. This steel is processed entirely in-house to maintain complete control over quality. Initial operations involve cutting and stamping the blanks, followed by a lamination process, a critical technical step that enhances grain orientation and blade integrity, inherited from the early German collaboration. The laminated blanks are then shaped, heat-treated through hardening and tempering processes, and undergo robotic polishing and sharpening to ensure consistent cutting performance. The blades are individually straightened, lacquered for corrosion resistance, and fitted with handles tailored for agricultural or industrial use. Handle design and material vary depending on the machete's purpose and destination market. The company's robotic systems now manage sharpening, painting, and packing phases, significantly increasing throughput while minimizing variability. Colma produces between 1 million and 1.1 million machetes per month, making it one of the largest single-site machete factories globally. Beyond machetes, the facility produces various forged and stamped tools using the same steel grades and forming processes, including scissors, trowels, and cutting tools. The plant features internal toolmaking and maintenance divisions to ensure precision dies and forming equipment are always operational. Their engineering team often replicates ancestral tool designs used by farmers for generations. Quality control is embedded in each phase, with manual inspections, test cuts, and material traceability procedures. With a workforce of around 900 employees and a highly automated production line, Colma blends tradition and modern technology to dominate the global machete market while continually expanding into new territories. Eastman Hand Tools utilizes advanced forging and heat treatment techniques to produce high-performance tools. The factory in Ludhiana features 9 forging lines, a wheel wrench upsetter, and press forging machines for cold stamp spanners. Heat treatment is performed using electric and gas carburizing furnaces to ensure uniform hardness. Tool surfaces are finished using automatic vibro machines, followed by in-house nickel, chrome, satin, or zinc plating. Dimensional accuracy and mechanical performance are verified through torque tests, hardness tests, 3D imaging, and UNIV. Kitchen Essentials uses the best raw materials sourced from reputed suppliers to ensure high-quality cookware. The manufacturing process involves several precise steps, starting with deep drawing to shape the metal sheets. Lid forming, spinning, and lipping follow to create perfect fittings and edges. Automatic and semi-automatic buffing polish the surfaces for a smooth finish. Riveting secures handles and other components, while anodizing and annealing enhance durability and corrosion resistance. Cutting, edge rolling, and hole drilling shape the cookware and prepare it for assembly. For non-stick cookware, specialized coating processes are applied, ensuring long-lasting performance. Additional quality measures include tempering and steel ball tests to verify strength and durability, along with steel rim fitting for enhanced structure. Kitchen Essentials also produces plastic jerry cans using blow molding technology. The Firstol Premium Tri-Ply range in cutlery manufacturing, featuring laser etching, showcase the company's technical expertise. Stringent quality control tests are conducted throughout production. Environmentally, the facility harnesses solar energy and implements rainwater harvesting, supporting sustainable manufacturing practices. Maruda and Chuki Company Limited, based in Inabe City, specializes in manufacturing and supplying cast iron products through a fully integrated in-house production system. The process begins with sand mold fabrication using both automated molding machines and traditional hand molding methods. Molten metal is produced in a cupola furnace, reaching temperatures above 1,500 degrees Celsius, annually. After solidification, the molds are dismantled, and the castings are cooled and extracted. Surface cleaning is performed using shot blasting equipment to remove residual sand. Burrs and parting lines are mechanically removed to ensure clean finishing. Depending on the product type, machining is conducted with lathes or drilling machines. Anti-corrosion coatings are applied to protect cast iron components. Gas valve units undergo pressure testing to detect any leakage. Combustion performance is individually verified through live flame testing. Only fully compliant units proceed to packaging and dispatch. This systematic and controlled process supports the reliable production of gas burners, cookware, and decorative castings, widely used in commercial kitchens, emergency response units, and events across Japan and overseas. ZOLLERN manufactures high-performance components using advanced casting, forging, and machining technologies with in-house alloy development and precise control over centrifugal, investment, and sand casting. The company ensures top material integrity. Forged rings and shafts are produced on automated ring rolling and forging lines. CNC-controlled machines deliver tight tolerances across all parts. Quality is verified through spectrometric, metallographic, and thermal tests. ZOLLERN also produces hydrostatic bearing systems, precision rotary tables, and custom gearboxes. Electromechanical drive systems and efficient motors are integrated for industrial and energy applications. Global service centers provide full support, diagnostics, and repairs, ensuring long-term performance across demanding industries. The assembly process of a starter motor is a systematic, multi-stage operation that ensures mechanical precision, electrical reliability, and performance consistency. It begins with core pressing, where the laminated iron core is hydraulically pressed onto the armature shaft. Accurate alignment is crucial at this stage to ensure rotational balance and electrical efficiency. This is followed by commutator pressing, a process that attaches the copper commutator to the shaft, ensuring it is tightly secured and aligned to facilitate proper current transmission through the brushes. Once the core and commutator are secured, hot stacking is performed. Here, preheated laminations are stacked onto the shaft under compression, forming the complete rotor core. Heating the laminations ensures better bonding and dimensional stability. The armature then proceeds to MVD, magnetic variation detection testing, a quality control measure that checks for uniformity in the magnetic field across armature poles. Detecting inconsistencies at this stage prevents imbalances and electrical faults later on. After passing MVD testing, the unit undergoes varnishing, a process where the wound armature is vacuum impregnated with insulating varnish. This enhances dielectric strength, reduces the risk of short circuits, and provides mechanical reinforcement. The varnish is then cured in a temperature-controlled oven. Following varnishing, the commutator surface is refined through commutator turning using CNC lathes. This guarantees surface concentricity and a smooth finish for optimal brush contact. Next, dynamic balancing is performed to minimize vibrations during high-speed rotation. The assembly is spun at operating RPMs, and weight is adjusted to achieve balance. In the brushing step, carbon brushes are installed into brush holders with calibrated spring pressures, ensuring continuous and low-resistance contact with the commutator. The rotor is then assembled with the rear end cover, REC, brush spring and armature, followed by installation of the front end cover, FEC, and yoke, which houses either field coils or permanent magnets. Tie bolts are inserted and tightened to a specified torque to maintain structural integrity. The motor is then subjected to magnetization, in which a pulse current is applied to magnetize permanent magnet rotors. Comprehensive performance testing follows, measuring torque, current draw, and speed under load. Leak testing is conducted to ensure that the housing is sealed properly, especially for waterproof models. Mechanical joints undergo nut and thread checking using torque wrenches and gauges. Noise level testing is carried out to detect anomalies, such as bearing whine or brush chatter. Lastly, a final inspection is conducted, verifying visual finish, electrical characteristics, and labeling. In many facilities, digital traceability systems and automated test benches are integrated into the process to ensure consistency and provide real-time quality data. Only units that pass all criteria proceed to packing and dispatch, ensuring customer satisfaction and long-term reliability in demanding automotive applications. Harder Group specializes in precision manufacturing using high-speed cutting machines with spindle speeds up to 72,000 RPM and tolerance levels down to 5 microns. They integrate coordinate measuring machines and optical inspection systems for advanced quality control. Depending on part complexity and batch size, the company deploys manual or automated workflows, including compound tooling and a mix of small and large presses. With strong automation, vertical storage for 8,000 pallets, and ERP-compatible logistics, they ensure efficient supply chains. Agile and customer-focused, Harder quickly adapts its portfolio to meet evolving technical and connectivity demands in modern manufacturing. Schaeffler produces a wide range of bearings using advanced, high-precision processes. Cylindrical roller bearings are machined for high radial load capacity with tight tolerances and smooth raceways. Tapered roller bearings undergo precision grinding for optimal axial and radial load handling. Wheel set bearings, vital for rail applications, are assembled with sealed units and factory-set clearances for long service life. Deep groove ball bearings feature finely ground raceways and tight ball track conformity for quiet, high-speed use. Spherical roller bearings are engineered with self-aligning rollers and robust raceways, ideal for heavy loads and misalignment. Each type undergoes rigorous testing for durability and reliability.
In the world of industrial manufacturing, where the demands on machine tools are measured in decades of service life, micron-level tolerances, and the ability to handle parts weighing hundreds of tons, Waldrich-Siegen stands as an enduring symbol of engineering excellence. Since its founding in 1911 in Siegen, Germany, the company has continuously pushed the boundaries of what heavy-duty machine tools can achieve. Today, Waldrich-Siegen is recognized globally as the leading supplier of high-performance machines in the fields of milling, turning, grinding, texturing, and boring, serving industries where precision is non-negotiable and reliability is critical. From portal milling machines that can shape massive steel structures to ultra-precision lathes capable of turning enormous components with flawless surface finishes, Waldrich-Siegen's portfolio is built to meet the challenges of the most demanding production environments. The company's machines are trusted in steel mills, power generation facilities, shipyards, aerospace manufacturing plants, and heavy engineering workshops worldwide. Waldrich-Siegen's portal milling machines represent the pinnacle of large-scale machining capability. Designed to handle exceptionally large workpieces, these machines provide unmatched stability and rigidity, critical factors when milling high-strength materials such as hardened steel or titanium. With state-of-the-art CNC control systems, they deliver repeatable accuracy even on components stretching several meters in length and width. Applications range from machining turbine housings and ship components to steel plant rolls and wind turbine hubs. The portal structure ensures excellent accessibility for both manual inspection and automated tooling systems, while integrated measurement systems allow real-time quality control during machining. In turning technology, Waldrich-Siegen has established a reputation for producing the most precise and durable lathes in the industry. These machines are engineered to process massive rotational parts with diameters often exceeding several meters, while maintaining micron-level tolerances. The horizontal turning lathes combine heavy-duty construction with sophisticated drive technology, enabling high metal removal rates without compromising accuracy. They are ideal for machining rotors, shafts, railway wheel sets, and large bearing components. Many are equipped with automatic tool changers, adaptive cutting control, and intelligent vibration damping systems that ensure consistent results even under extreme load conditions. For components that require both deep internal machining and complex external milling, Waldrich-Siegen's boring mills and milling machines offer the perfect solution. Their modular design allows for customization according to specific customer requirements, be it extra-long spindle travel, integrated rotary tables, or multi-axis capability. These machines are widely used in energy equipment manufacturing, such as boring and milling housings for hydroelectric turbines, gearboxes for wind power, and casings for large compressors. Precision linear guideways, hydrostatic bearings, and thermal compensation systems ensure optimal performance over years of heavy operation. Since its inception in 1911, Waldrich-Siegen has remained committed to German engineering quality, with every machine manufactured to withstand decades of intensive use. This commitment has made the company a trusted partner for customers who value long-term investment returns and minimal downtime. Their production facilities combine traditional craftsmanship with modern manufacturing techniques. Each machine undergoes meticulous assembly, precision alignment, and rigorous testing before delivery, ensuring it arrives at the customer's site ready for reliable operation. Alongside Waldrich-Siegen, the Hercules Group represents the pinnacle of roll machining technology. Hercules specializes in roll grinders and lathes, machines critical for producing and maintaining the rolls used in steel, aluminum, copper, and paper production. Rolls are the heart of any rolling mill, and their surface finish, roundness, and geometry directly impact the quality of the finished product. Hercules machines ensure that every roll is machined to perfection, achieving the highest possible performance in operation. Hercules roll grinders are engineered to meet the extreme demands of high-capacity rolling mills. These grinders can process rolls weighing up to 300 tons with lengths exceeding 15 meters. Using advanced CNC control systems, they achieve surface finishes down to the sub-micron range, ensuring rolls operate efficiently and produce flawless sheet or strip products. Integrated measurement technology allows for automatic profile correction, meaning the grinder can adjust in real time to compensate for wear or thermal distortion in the roll. This guarantees consistent quality and extends the roll's service life. Hercules goes beyond supplying individual machines, offering complete roll shop solutions. This includes designing, building, and delivering all auxiliary equipment such as roll lathes, roll handling systems, automatic roll loaders, balancing machines, and roll cooling systems. By providing turnkey roll shops, Hercules enables customers to have a fully integrated, automated workflow from roll removal and transport to grinding, inspection, and reinstallation. This reduces handling time, improves safety, and ensures that each roll meets strict operational standards before returning to service. Both Waldrich-Siegen and Hercules have embraced automation and digitalization as key drivers of efficiency. Their machine tools can be fully integrated into Industry 4.0 environments, with networked monitoring systems, predictive maintenance software, and real-time data analytics. For example, a roll grinder can continuously record grinding forces, spindle loads, and temperature variations, transmitting this data to a central monitoring system. Operators and maintenance teams can then predict potential issues before they lead to downtime, optimizing both productivity and machine lifespan. From the steel industry to the cutting-edge world of aerospace, the applications of Waldrich-Siegen and Hercules machines extend across some of the most demanding sectors on the planet. In steel and non-ferrous metals, these machines are trusted for the precise machining and maintenance of rolls, mill stands, and other vital plant components, ensuring smooth, efficient, and reliable production. In the energy sector, they play a pivotal role in manufacturing large turbines, generator components, and housings, whether for renewable power facilities like wind farms or for conventional power plants, meeting the tightest tolerances and operational demands. In shipbuilding, Waldrich, Siegen, and Hercules bring unmatched capabilities to the machining of colossal propeller shafts, stern tubes, and heavy structural elements that form the backbone of ocean-going vessels. For aerospace, where precision can mean the difference between mission success and failure, these machines are instrumental in producing high-accuracy structural parts and robust landing gear components, meeting exacting aerospace standards. In the rail industry, their expertise extends to the manufacturing of complete wheel sets, axles, and bogie frames, ensuring durability, safety, and performance for passenger and freight transport alike. Wherever massive, high-value workpieces require absolute precision and reliability, Waldrich, Siegen, and Hercules deliver solutions that define industry benchmarks. Machines built not just for size and strength, but for the uncompromising quality that the world's most demanding applications require. One of the hallmarks of both brands is their commitment to machines that last for decades. Many Waldrich, Siegen, and Hercules machines from the mid-20th century are still in operation today, testament to their engineering integrity. This philosophy goes hand in hand with comprehensive after-sales support, including spare parts supply, machine modernization, CNC upgrades, and on-site training. Customers benefit from not just a machine purchase, but a long-term technical partnership. For over a century, Waldrich Siegen has been synonymous with heavy-duty, high-precision machine tools, while Hercules has led the world in roll machining technology. Together, they form a powerhouse in industrial manufacturing, offering solutions that combine brute force with finesse and tradition with cutting-edge innovation. In industries where failure is not an option, their machines ensure that every component, be it a massive turbine housing, a finely finished roll, or a precision machined axle, is made to exact specifications every time. With ongoing investments in automation, digitalization, and customer-focused engineering, Waldrich, Siegen, and Hercules are not just keeping pace with the future of manufacturing, they are shaping it.
DataPro International utilizes advanced Datron CNC technology to precisely mill and engrave aluminum control panels, display plates, and electronic enclosures. The key to their success lies in Datron's high-speed machining capabilities and integrated vacuum table system, which securely holds thin sheet metal during operations. Using a combination of small-diameter carbide tools and high spindle speeds, often exceeding 40,000 RPM, DataPro achieves clean, burr-free edges and highly legible engraving on anodized surfaces without secondary finishing. Each panel is programmed using Datron's intuitive software interface, allowing for rapid design iterations and efficient batch processing. Toolpaths are optimized for minimal material waste and maximum surface quality, ensuring consistent depth control and sharp contour definition, critical for precision electronics labeling. Engraving features, such as serial numbers, logos, and port identifiers, are machined with micro-end mills that maintain clarity, even at small font sizes. For milled features like cutouts, radii, and slots, tool changes are automatic, and cooling is handled through a minimal quantity lubrication (MQL) system, reducing thermal distortion and tool wear. With this Datron setup, DataPro streamlines its workflow, delivering custom fabricated panels with exceptional detail and dimensional accuracy across diverse production runs. The eMuge CircGF Indexable Thread Mill is a high-performance circular thread milling tool featuring exchangeable face inserts. Designed for both internal and external threads, starting from M12, it offers two sizes for enhanced flexibility and adaptability across various applications. Suitable for nearly all materials and thread systems, it ensures precise threading on components made from C45 over 1.0503 steel, with a tensile strength of 750 N per square millimeter. The profit milling strategy demonstrated on the Mori Seiki NVX 5080 Machining Center showcases a significant leap in milling efficiency. When machining a CK45 aerospace component using a 20 mm Paul Horn end mill, the traditional cycle time of 52 minutes is drastically reduced to just 14 minutes with profit milling, a time savings of over 70%. This high-efficiency roughing method maintains a constant tool load, allowing for higher feed rates and deeper engagements. In this case, the feed rate reaches 6,000 millimeters per minute, with a feed per tooth of 0.38 millimeters and a spindle speed of 5,000 RPM. The tool operates at an optimized engagement angle of 25%, with an impressive axial depth of cut of 35 millimeters. These parameters are made possible by profit milling's constant engagement principle, which minimizes heat generation and extends tool life by over 500%. The result is faster cycle times, reduced machining costs, and significantly improved productivity, ideal for high-value aerospace components where precision and efficiency are critical. At Wärtsilä's diesel engine production facility, Waldrich Coburg's heavy-duty gantry machining centers perform key precision operations on oversized engine components. Each diesel engine block undergoes rigorous machining processes, including multi-axis milling, drilling, and boring. The machines feature hydrostatic guides and high-torque spindle drives for enhanced stability and tight tolerance control, crucial for the alignment of cylinder bores and sealing surfaces. This setup is essential for Wärtsilä's high-output engines, where thermal efficiency and component durability depend on micrometer-level machining precision. Dart billet blocks and heads are crafted from solid aluminum, tailored for extreme racing performance. Starting with a 500 pounds billet, Dart machines it down to a 150 pounds engine block, capable of producing over 3,000 horsepower. Each piece is custom designed in CAD to meet specific racing needs, offering options like tall decks, wide bore spacing, and revised lifter angles. After precision machining and heat treatment, components undergo strict quality control. Dart's billet program empowers racers with fully customized, high-strength engine platforms built for maximum power and reliability. The SIA Cut Center in Latvia is a high-capacity steel service facility, processing 2,000 tons of steel per month. It features full Wortmann system integration with interconnected machines controlled by VCAM software, allowing centralized order preparation and production monitoring. A central roller conveyor links every machine, enabling automated material flow and efficient routing. Key systems include the V630T drilling unit with 3 independent heads for simultaneous flange and web drilling, and the VB1050 saw with servo motors for high-speed, precision cutting. The V806 handles complex 3D cutting and marking on profiles, while the V320C processes plates with plasma/oxy fuel cutting, drilling, and layout marking. Automated conveyors and minimal operator input streamline workflow, while the blasting and painting line includes preheating, abrasive removal, and drying stages. Wortmann's design ensures optimal productivity, flexibility, and precision across the entire plant.